Welcome to Chapter 8, where we're going to discuss ionic strength and activities. So this chapter is just expanding a little bit more about equilibrium to some non-ideal cases. We're not going to go into a great deal of depth into this, but I do want to introduce this idea of ionic strength and activities because it is critical to how some analytical techniques work. Understanding that activity was what actually matters in equilibrium, and concentration is just an approximation of that. So let's explain what I mean by all of that. Regular concentrations are great and simple to understand, right? If we think about molarity of a system, we can calculate that directly if we know the number of moles per liter of solution. And so that is straightforward. And when we calculate an equilibrium constant K, to the first approximation, we put in those concentrations in molarity, right, of products and reactants to the appropriate stoichiometric coefficients. But it turns out this doesn't always work. So let's give and particularly for ions. So ions are quite non-ideal. So just to give a practical example of how this works, let's look at calcium sulfate. So when we looked at equilibrium and the solubility of salts like this, right? So calcium sulfate is a sparingly soluble salt in water. We can write down the KSP for it. It's about 2.4 times 10 to the minus 5, so we wouldn't expect it to be very soluble. And the solubility is about 0.015 molar in pure water. So meaning that we would expect concentration of calcium and concentration of sulfate to be about 0.015 molar in pure water if we can measure it that way. But if we add a salt that doesn't actually react with either of these components, right? So we add potassium nitrate. So nitrate does not react with calcium. Potassium does not react with sulfate. All right, this does not form a precipitate or anything like that. At a concentration of 0.050 molar, the solubility increases. Meaning that we get more ions dissolving from the salt if we add a different salt to the solution. And that seems pretty counterintuitive. It's sort of the opposite of the common ion effect, which decreases it, but that's because it's directly involved in the equilibrium. In this case, the potassium and nitrate, they don't show up in the equilibrium constant. So the question is, how are they affecting this? Right, so how is this happening? And this is where this idea of ionic strength and activities come up. And so we'll start looking at that in the next video.